Hello, and welcome to Auto Be Careful, the place for car safety, news, and information. I'm Gene, and today we're going to talk about how the rise in electric vehicles is causing challenges for the military and our road infrastructure. First, a bit of background. Every year, thousands of fatalities occur from 100,000 vehicle run off road collisions that involve roadside barriers and other infrastructure. According to the U.S. Department of Transportation, vehicle run off road crashes account for 30 to 40% of all vehicle related fatal crashes annually. Roadside barriers are critical to the safety of road users as well as whatever's behind the barrier, including buildings, pedestrians, and wildlife. There are several different types of roadside barriers, including steel, concrete, and wire. Steel guardrails were developed in the 1930s, with concrete barriers being developed in the 1940s and wire barriers being deployed in the 1960s. Current versions of all these types are still widely used throughout our highway system. Over the years, these barriers have become more refined and updated, especially as vehicles have changed. In addition to being important for road safety, the military closely monitors these trends to protect against hostile vehicles. Recently, there's been a major shift in vehicles used on the road, with electric vehicles gaining in popularity. These vehicles behave differently in a collision, in part due to their weight. As more and more electric vehicles arrive on our nation's roads, as well as roadways around the world, there's been renewed interest about whether or not these barriers are up to the task of protection. Let's take a look at the two systems that have been around the longest: steel and concrete. A current version of the steel barrier is called the Midwest Guardrail System, or MGS, and it was developed in response to issues with previously used barriers. These previous barriers had issues with barrier failures as well as vehicle rollovers. The MGS has been tested against small cars that weigh about 2,400 pounds and trucks that weigh about 5,000 pounds. The current version of the concrete barrier was developed in the 1950s. These concrete barriers are tested against similarly sized vehicles as the steel barriers. Unfortunately, there are multiple vehicles on sale today that exceed 9,000 pounds, which is twice the weight of these test vehicles. With that in mind, the US military has sponsored research at the University of Nebraska-Lincoln to see how these current barriers fared against electric vehicles. Two tests have been performed so far that support the concerns that these barriers may not be up to the task of stopping an electric vehicle. In September of 2023, a Tesla Model 3 drove through a steel guardrail by pushing the guardrail up and over the car before the vehicle came to a stop past the barrier. In October of 2023, a Rivian R1T was driven into a similar barrier, ripping through the barrier entirely. The truck then proceeded to drive over a second concrete barrier that was used as a backup before coming to a stop beyond both. The Tesla weighed in just under 4,000 pounds, while the Rivian weighs over 7,000 pounds. As I mentioned earlier, one of the concerns about these barriers is their inability to stop electric vehicles because of their weight. But I also mentioned that these barriers have been tested against 5,000-pound trucks, which is heavier than the 4,000-pound Tesla. Studying this data is still in progress, but the data suggests it's not just the weight of electric vehicles that causes an issue, but where the weight is distributed in the vehicle itself. Gasoline-powered vehicles typically carry their weight much higher than electric vehicles. This is because most of the weight of a gasoline vehicle is in the engine and transmission, which are typically mounted on top of the frame. In contrast, electric vehicles typically have their heaviest component, which is the battery, mounted inside the frame. As a result, the momentum of a gasoline-powered vehicle will typically be dramatically reduced by a barrier that's designed to cushion the impact at the height of the engine. In contrast, the momentum of a battery inside an electric vehicle will typically hit the lower supports of that barrier where there's little to no cushion. So how do we solve this problem of creating a barrier that can stop electric vehicles while also continuing to stop gasoline-powered vehicles? One proposal is the SAFER barrier, which was developed by the same University of Nebraska-Lincoln that conducted these barrier crash tests. This barrier was first put into use in 2002 at the Indianapolis Motor Speedway and is currently in use in many raceways throughout the nation. These barriers use a combination of steel tubes, concrete, and polystyrene foam to reduce and dissipate the impact of a vehicle, resulting in less energy being transferred to the vehicle's occupants and typically less damage to the vehicle itself. Since being implemented in several raceways, it's starting to find its way onto our roadways as well. And since it's designed to absorb the impact at any height, it has benefits for both gasoline powered and electric vehicles. Now, it's still in the early stages of solving this problem, and there are likely to be many more designs proposed and tested before a final successor to the current barriers is chosen. The effort to solve this problem is expected to take years before road infrastructure is overhauled, but the future looks promising for increasing the safety both of electric vehicle drivers as well as gasoline vehicle drivers. As always, thanks for watching. I hope you learned something, and remember to like and subscribe.